Hello, my name is Konstantinos Gavril. I'm a teacher of physics, and the video you are watching is about the current divider. We are going to see a circuit that is called current divider. And as you can realize, we are going to divide uh, uh, an electrical current. How? By connecting the two resistors in a parallel way. In the previous video, we have seen the voltage divider circuit. There, we had two in series way connected resistors, okay? And now we have a current divider circuit, which means that we are going to divide the current. And how are we going to do it? By connecting two resistors in a parallel way. Let's see now, we have this circuit here, 6 volts in the voltage source, R1 and R2 are equal to 10 kilo ohms each one. Now, as you will realize, or as you can um, maybe how we can say, if we can predict, okay, we are going to have equal currents passing through each one of these two. Let me show you each one of these two branches. This is a branch, and this one is another branch. Okay, we are going to have a current flowing through this part of the circuit, and here it will be divided into currents. These two currents will have equal value because of the equal values of the resistors. Let's see in our simulator what will happen. So I'm going to draw this circuit, inputs and sources, add the voltage source in with the two terminals, draw, add wire here, okay, and also I'm going to add a wire here before I connect it to the resistor, add the resistor, right here, be careful the connections, we have already explained in the previous videos. Okay, here is my first one, let's draw, select and drag in order to select this point and make it a little bit larger. Okay, now I will use the draw option, add wire. Here I'm going to add a wire. Okay, you see, now I'm going to add another wire and another wire here. I will connect another resistor here in a parallel way, draw, add wire in order to close this circuit right here. And so you can see that we have 1 kilo, but we need to change the values in 10 to be 10 here, kilo, and this kilo means kilo ohms, but we don't write ohms, we write only 10 kilo, apply and okay, double click here, apply and okay, 10 kilo ohms here. We have the voltage to be 6, double click on the source, 6 here, okay, apply and okay. And now, what do they ask from us? We are going to fill these tables. We have 6 volts, 10 kilo ohms each resistor. Here I'm going to enter 6 volts. Okay, I have a 6. Going to make it in the center. Okay, I have a current at point A and a current at point B. Okay, what happens here? I have an A and a B. Okay, I'm going to insert here an ammeter. I'm going to remove this wire and I will choose select and drag. Okay, and I will insert outputs and labels in order to enter an ammeter. Check here. We have an ammeter. Super. You see now, I'm going to explain you something. If I want to change the um, the polarity of the ammeter, which means the direction of the arrow of the ammeter, I can make a right click on it and we have to swap the terminals. Here on the last option, let me use my cell, this tool, swap terminals, and choop will be in the opposite direction. And as you can see here, I have a minus, minus 1.2 milliamperes. Why? Because the ammeter is the opposite way uh, inserted. Okay, the current flows to the right direction and the ammeter polarity is the other one. So we are going to have a right click, swap terminals and make it like this. Now, I'm going to remove the other one also, drag, don't forget, because if I'm going to do now, if I try now to remove it without choose, without choosing this select, look what will happen. Okay, I have the previous option. So I choose the select from the drag. I remove it because I don't care about it now. And I will insert my new ammeter here, from here to here. Okay, as you can see here, I have milliamperes and here I have amperes. But I will double click here on the ammeter, here, and I will choose the scale option, milliamperes, apply, and OK. And now I'm OK. As you can imagine now, what will happen to the current? I'm going to explain you a couple of things. According to the Kirchhoff's law, I'm going to have I to be equal to I1 plus I2. Yes, imagine that this one is I. Here I have I1 maybe, and I2 here. Okay. As you can see, I have 1.2 milliamperes incoming, and I have here two outcomes. The one of them is 0.6. As you can imagine, the other one will be 0.6 also, because I need to have totally 1.2. So 0.6 plus 0.6 gives me 1.2 milliamperes. Okay, so as you can see, I have two currents with the same value. Why? Because I have the same values of the resistors. Okay, here. So I divide the current of 1.2 milliamperes here in two equal currents. How? Here by using a parallel connection resistors, okay, with a DC circuit. Now we are going to fill the table here. It will be 0.6, 0.6 here. I'm going to make it in the center, 0.6 here also, because we have explained it is, we have equal. Okay, now we are going, I'm going to clean this mess a little bit. Okay, we have just a moment, please. Okay, now we have what we have here, 6. Okay, now we are going to have a 9 volts with 10 and 10. And we are going to realize that the same thing happens. Okay, I don't care about. Okay, I will double click on the source. I will make it 9, the value. Okay, and now you see that I have 1.8 milliamperes and the half of it, okay, passes through the one branch from here, okay, and the other half 0.9 from here because I need to have to get 1.8 milliamperes. So I'm going to fill this again 9 here. Here I have 1.8 and the 0.9. I will make them in a center way. Whoops. Center and perfect. Okay. Now, lastly says swap resistor R1 to 1 kilo ohm. I'm going to change the value of this one. Okay. And we'll make it 1 kilo ohm instead of 10. Let's see what happens. And you realize what will happen. I will make it 1. Double click, make it 1. As you can see, I will predict now what will happen. I'm not a medium, okay? I'm not a magician, I'm not anything, but I use my science to predict. And what do I predict? I will have higher current here. Okay, 9.9 here. Let me see. Here you see 0.9. Okay, the current, most of the current, here it is 9 again. Okay, okay. As you can see, let me change the color of my notation. Here we have 0.9 milliamperes and here we have 9.9 milliamperes. So as you can realize, here I'm going to have 9 milliamperes. Okay, because I'm going to explain you. I will have 9 milliamperes here. Okay, because this plus this needs to be 9.9. You see, here I have the incoming current and here is the two outcoming currents. So one of them is 0.9, but the other one is 9. Okay, you see it is much more higher, 9 and 0.9. What do we realize? Let's see the relation between these two resistors. My resistor here is 1, okay, and here is 10. So I can see that I multiply by 10, okay, the resistors. The same thing happens with the current. Maybe, the same thing in inversely inverted way. Okay, now the current is divided by 9. Okay, the current here, let me show you a detail in a better way. Here I have 0.9. Okay, here it is 0.9 and here it is 9. So in this direction happens this, the opposite. Eh? Okay, or I can explain you with the arrow to be in the other direction. This is divided by 10, because if I divide 9 above 10, it will be 0.9. So as you can realize, the current divider circuit divides the current depending on the values of the resistor. If I have an enlargement, let's say, and if I multiply by 10 the value of the resistors, the current will be inversely proportional. So it will be divided by 10. And it is normal this. Why? I have the Ohm's law, okay? And I have the R to be V above I. Now the V is equal, okay, here and here. Now the value of the V is equal here and here. So if I have here, or I will stop, not make it complicated for you. Okay. So the main point, the main meaning of this exercise is to see that when I want to divide the electrical current, I use the resistors in a parallel way, and I use specific values in order to get the division that I want. That's all, and we are going to continue with another video.